morning, good afternoon, good evening, everyone. Welcome to the second session of the lecture series on systematic characterization of tailing for an efficient utilization. On the first day, we had Professor Nilo Cesar Consili and Professor Sumi Siddiqui with us. Today, I request first Dr. Chungchi Cherian to invite Dr. Prachi Kaul and with the further.
Hello, everyone. Once again, welcome to today's session. I'm very happy to welcome Dr. Prachi Kaul to all of you and to welcome her to this session. And I'd like to give a short introduction to Dr. Prachi Kaul. So Dr. Prachi Kaul is the director of the Shastri Indo-Canadian Institute, that is SICI, for its office in India. And she has been associated with this institute for more than 17 years now. An alumna of Indian Institute of Technology, Delhi, Dr. Kaul has served and is associated with various international and national bodies such as World Bank, Asian Development Bank, UNESCO, Plan International, and the National University of Educational Planning and Administration before joining the Shastri Institute. Dr. Prachi Kaul is a social scientist with a keen interest in studying the aspirations and social mobility of the masses and its relation to higher education. Dr. Kaul serves on various advisory boards of academic and research institutions, and Dr. Kaul is also a member of binational joint working groups of governments of India and Canada, that is the Science and Technology and Higher Education. So once again, a hearty welcome, Dr. Prachi Kaul. Yeah, the floor is yours.
Thank you, Mr. Cherian, for this kind introduction. Very pleased to be part of this event, which is, I think, second leg of the program that was that is funded by the Shastri Indo-Canadian Institute. It's delightful to see the collaboration coming through so very well and the engagement of young researchers and students in this particular activity. We strongly believe that engaging with the young researchers and young fraternity is very, very important and need of the hour for both the nations, worldwide, of course, but here we are specifically talking about India and Canada. So it is very important that we enrich and we capacitate enough our young generation of researchers who will carry forward the work that have been initiated by our seniors. So I congratulate both the professors from India and Canada for building this program and enabling a mechanism by which greater participation is enabled for younger lot of researchers. So that is wonderful to see it's happening. Congratulations to the leads of this event, and I'm sure they would be able to take it forward, wherein the leads will be passed on to a couple of people who are in the string, who are going to be taking over more and more responsibility. We at Shastri Institute find it very, I would say, fulfilling in terms of bringing two parties together, forming alliances, forming partnerships, forming collaboration is something that Shastri believes in. And with its existence for the last 53 years, we have been quite successful, I would say, in bringing this people-to-people connect between India and Canada. How we have done it by engaging with, institutions and people in various manners. So first we support by giving financial support, which is, of course, how this event is happening, to organize academic events, to bring people together from this bilateral terrain. Beyond that, there are provisions of various types of fellowships and scholarships, grants, that allows individuals to gain first-hand experiences in a respective geography. So Indian students and faculty, and for that matter, I'm very pleased to share with you that our programming is so widespread that it serves from the beginners, I would say from undergrad to postgrad to, you talk about PhD programs, postdoctoral fellowships, you talk about young faculty to established faculty, or any other domain of academia and research fraternity. I don't think anything remains untouched from Shastri programming. So it's a wide range of programming, array of programming that we offer to you to explore and find one that is more suited for your requirement. So these are the programs that allows you, bring some financial assistance to you to experience the other labs in Canada or India, or to visit them and spend some time with the professors who serve as your affiliate. So that is one mechanism. The other mechanism is that we provide you a wide network of excellent institutions. We are a platform with 170 institutions on board, and you name a good institution and you'll find it on our network. And that is the best thing to happen for any institution, to have a credible institution to partner, because we believe that while we are talking about the best of the best, we must ensure that the collaboration that is being formed through our assistance is of great repute. So we ensure that only and exclusively institutions of excellence are there for the networking purposes. Beyond that, we also believe that capacity building is very, very important for the other institutions as well. So while this network have been created with a lot of caution and care, we have started serving to or assisting Government of India by reaching out to middle level and low level institutions. When I say middle level and low level, where I'm talking about the internationalization in those campuses. So we are trying to assist them by bringing Canada to their campuses or taking them to Canada and help them and handhold them to explore what are the possibilities of collaboration. It is not so that they are not producing good work, they are doing, but they are not able to reach out to the correct partners. So that's what our agenda is for the time to come. We are going very focused in programming, and since this is the right platform to propagate this, I would like to inform you that we are shifting our orientation towards cluster programming, and on 15th of March, we have launched a cluster, which is called Agri Cluster on Bilateral Corridor. Similarly, we are going to bring in other clusters as well that will include artificial intelligence and robotics, sustainable habitat, language, culture, and society, of course, One Health, and likewise. So there are going to be different clusters being introduced by Shastri, which will facilitate to bring together all the major stakeholders, all the major players in that particular domain to come together and try to understand the complementarity and differences on this bilateral corridor. And bringing them together will also help them to negotiate, to navigate the issues and the matters of concern for both the ends and for the larger society worldwide. So that is the approach that we are going to take for future, I would say for next couple of years. And I suggest that any one of you who may be interested in these precise areas, you can get more details from the website, or you can reach out to the consent program officer, and she would be happy to extend any information that can help or may help you devising your plan of action for to collaborate on those areas. So this is futuristic planning, but for today, I would come back and I would say that it's wonderful to see great program ahead, great line of speakers. I'm sure this is going to be very enriching for those who are going to participate, and they will not just enrich now, but will get encouraged to take it forward for the betterment of themselves and for the people who are involved in this area for that matter. So thank you so much for having me today with all of you. Have great deliberations, all the very best, and take care of yourself. Thank you.
Thank you, Dr. Kaul. We really appreciate that you come here and give an introduction speech about the Institute. And we appreciate the award. And this is really help us to get together some good speaker and run the program today. Thank you very much. Thank you for all the support.
Thank you so much, Sumi, and it's lovely to see you here. And looking forward to meet sometime in person as well when you travel to India.
For sure. Thank you.
Yeah, thank you.
My name is Romy Sadeldin, and as introduced in the beginning of the lecture, I work as an associate engineer at Stantec, and my lecture today will go through some basic concepts for geotechnical investigation programs for mine waste facilities with some examples from a geotechnical investigation program for a proposed waste rock and mine tailings facility in northern Quebec. So just to give you an idea about the different elements that we deal with in engineering projects related to mine waste management, and I think some of the topics included in my lecture was covered by other presenters as well in this series. But that's the way we have to always remind ourselves of the main elements that we have to review as part of geotechnical characterization projects for mine waste facilities, which including reminding ourselves of the causes of failures of tailing dams and other important factors that impact the stability of these dams. So the main elements we deal with in mine waste facilities includes the tailing dams, obviously, and also the waste rock piles or dumps as resulted from the mine waste development. So in order to come up with an engineering program or study for a new development, we have to do a lot of research at the beginning to understand the history of the area and review the geological maps. Also, other experts will be involved in the geochemical sampling associated with identifying the mineral deposits in the area, things related to also the geophysical investigations and how we can understand the physical properties of the mine operations. The engineering studies, which my group and our geotechnical engineers get involved in, is basically the geotechnical support and the slope stability analysis required to confirm the design of the tailing dams and also the stability of the foundations of the mine facility. So as introduced before, so basically in order to develop a site or during the mine life of the mining operations, operators like to stage the construction of the mining facilities over the mine life. And that's basically it provides a low initial cost, and as they produce the mines, they can invest more in the construction of the dams, and also as more materials are being produced as a result of the mining operations. So basically, we start with a starter dike, and then the dam gets sized for initial tailings, let's say 1 to 3 years, and then the subsequent lifts are made as more tailings are produced. So as indicated, this will result in a low initial cost and flexibility in material selection. The disadvantage of this way of managing the site is basically it's the responsibility of the mine operator, and the planning and the scheduling of the construction is always required as more materials are being produced, and maybe changes as the mine is being developed may also be introduced in how the materials are being stored on site and how the dams are being built. So in the stage construction, maybe most of us know that we deal with different type of constructions or construction methods, which include upstream construction, downstream construction, and centerline construction methods. So to understand the different type of construction methods, here, this is just a quick visual of what the different methods are based basically on. So in downstream construction, just to highlight, it requires a large amount of materials, and that's a disadvantage to the mine operators. But it provides good stability of the dam, and also in the design we have to incorporate a drainage layer to maintain a low phreatic surface within the dam structure. And that provides good stability of the dam in the short term and the long term as well. And things to highlight about the upstream construction method. So basically it requires less materials to build them. Foundations of the future lefts are always supported on unconsolidated tailings, which is a disadvantage from a stability point of view. And normally you don't install drainage layer, and in that case, higher phreatic level is expected and has to be incorporated in the design in order to or check the stability of the dam and offer the right design for the dam as it's being developed during the mine life. The centerline method, which is the last one here, the lefts are centered over the top of the starter dike. So as you can see in this image, the material requirements are midway between the upstream and downstream construction methods, and they always incorporate drainage layer within the dam, which is offers more stability for the dam. Another element that we deal with in mine waste management is the waste rock piles or dumps. So they are always huge and to very high elevations. So the stability of these piles always a challenge to deal with, and assuming the right parameters is an important element in checking the stability of these piles. So also the other interaction with the environment and how this may impact the stability of these piles is another important element that has to be dealt with during the design stage. So overall, in mine waste management, to summarize, so we deal with the stability of embankments, which depends on the shear strength parameters or properties of the tailings, of the waste rock, and the foundation, which is basically supporting these developments over the time. So the shear strength of the deposit material is a key factor, and we always have to assume the right parameters for friction and cohesion of the foundation soil, and also we have to predict and assume the right groundwater levels within the soil profile in order to come up with a representative factor of safety in the short term and the long term for such sections. As I introduced in the beginning, we also have to remind ourselves what are the main causes of filling dam failures, and this was just presented in the lecture before my lecture. But just going through the different or the main factors that we always have to check during the design stage, which is always the overtopping. And overtopping is a big factor that, or sometimes, when we review the causes of dam failures, it might be a combination of different factors. But one of the main factors is always the overtopping. And overtopping is always something hard to confirm unless you have a very good review of the materials that are predicted to be produced during the mine life, and also how the water level or how the elevation of the dam structures is compared to the maximum elevation of the retained materials or the water bodies in hydro dams, for example. So failure of mine facilities are always huge and result in big losses in lives and other big failures downstream of the dam. So it has to be always checked during the mine life and revisited as changes are introduced to the operations of the mine facilities. So instability is also another factor, and it includes the static slope stability and the earthquake seismic stability. So proper design, proper assumptions for soil parameters, for also seismic parameters and the right earthquake or the design earthquake are important factors in the design of dams. And also, it also remains a factor which is unknowns. Unknowns, sometimes, going back to failures from documented information, not always helpful to come up with the right cause or the mean or the major cause of the failure of certain dam. This is another illustration for causes for failures of dams, and this incorporates a little bit the hydro dams in addition to other type of dams. So basically, and that also is applied for mine facilities. What kind of dams we're dealing with? Are we dealing with concrete dams that's used to retain materials? Are we dealing with rockfill dams? Are we dealing with earthfill dams? So each type of these dams require the right engineers to analyze and assume the right parameters for the design. Also, it requires the right investigations to support the design. Again, a big emphasis on overtopping and how this has to be always incorporated in the design, piping, and how seepage can impact the stability of embankments and dams. Other factors include structural factors and slope stability, seismic analysis, and earthquakes and the assumed earthquakes in the design. So an overview of the different factors we consider in the design. So in dam stability analysis, different design loads includes water levels behind the dam shall be always considered to check the factor of safety in long-term, short-term cases. This typically includes the full reservoir case, which is the maximum load that is expected for the dam structure. Other cases which are also equally important is the rapid drawdown, and rapid drawdown is sometimes is significant in the stability of slopes of embankments, and we have to always check and analyze such design case in order to confirm the factor of safety against failure for rapid drawdown cases. Understanding of the foundation of the dam and assuming the right parameters is always important and has to be considered in design in order to come up with a representative factor of safety in the different cases. So as I mentioned, I'll be presenting an example from a proposed development, and that's a study we were involved in to support the feasibility study required for the mine operations, which was located in James Bay in northern Quebec. So the operations included an open pit, and the ore will be crushed on site to pea-size gravel materials. The mine life was estimated to be about 16 years, and the ore feed is about 2 million tons per annum for the mine development. So two main elements here we're dealing with: waste rock as being generated from the mine operations, and the total was estimated to be 62 million cubic meters. The dam was designed to be an open pit, and the tailings, the volume was estimated to be about 15 million cubic meters, and the size is between 8 to 12 millimeters in diameter. This map shows the different features within the development. This is the footprint of the proposed waste rock and tailings storage facility. As the site being developed, also other elements, including the peat stockpile and overburden stockpile, was considered in the design. Also, a pond for drainage was also considered in the design, and was incorporated in the analyses of the stability of the mine facilities. So, in order to come up with, the geotechnical model, and also to analyze the stability and other elements that we talked about as part of geotechnical support to mine facilities, boreholes were drilled by our firm and others to confirm the stratigraphy and of the subsurface layers, and also the engineering properties of the soils beneath the proposed tailings and waste rock facilities. Locations and a lot of issues related to access to the site, and also weather conditions were always factors to deal with in investigations like this, and sometimes refusal of boreholes, and also other factors affecting the sampling of the clay in this site, and we'll talk about this in a little bit of detail in the next few slides. So the overall objective was to cover the area with enough boreholes and also concentration testing in order to have confidence in the geotechnical model that can be used in the analysis of stability and other analyses required as part of this program. So just to give you an idea about the geology of the area, so the area includes sedimentary soils, and also the bedrock is near the surface, and was estimated to be a little bit variable within the site, and the geology was related to the east mean inferior group, and the surface clay deposits are known to be of a varved structure, and it's a soft soil deposit, and that was a challenge to deal with in this study, and we will go through some of the challenges dealing with foundations of soft clay for such developments, and how to deal with something like this in the analyses and also in the construction methods proposed for the development. So one of the tasks that we had to deal with, just that's worth mentioning, is after the initial program was introduced and after confirming the soil properties within the development, an additional program was also introduced to the client in order to confirm the subsurface conditions. And again, that is due to the challenges that we had to deal with because of the soft nature of the clay within the site. As mentioned, the bedrock wasn't too deep within the site. This here shows the bedrock elevations within the area. So based on the borehole information and also confirmed by the geology of the area. As I said, that was just to support the feasibility study. Probably in the next stage, more boreholes, more analysis will be required in order to confirm the findings of the feasibility study of this mining development. So as mentioned, the clay was of soft nature, and that's why we introduced using the concentration testing to confirm the clay behavior and performance or engineering properties of the clay below the proposed development. And the good thing about concentration testing that we can use the data to also confirm the classification of soils that we can also confirm using just grain size distribution and hygrometer, but also using CPT sometimes gives you an idea about what you would assume for the clay, and also confirms the depth of the clay. And it's another way of drilling or testing the soils to have two sources of data in building the geotechnical model. So according to the CPT data, the points were scattered, but the majority of the boreholes yielded a classification of clay to silty clay soils, and also which was in with agreement with laboratory testing. So since we mentioned soft clays and the difficulty to deal with soft clays, so one of the main factors that we also have to check, and that's impact the analyses and also impact the approach that we have to deal with for developments like this, is first of all we have to understand, or we have to check if the soft clay is classified as sensitive clay or not. And fortunately, within that development wasn't really sensitive and wasn't an issue, but the different definitions of sensitive clays always have to be incorporated. You can't just rely on sensitivity only, you can just rely on the molded strength. So the objective of this slide, just to remind ourselves what are the different ways we can use the liquidity index as an indicator. We can use the remolded shear strength of the clay and sensitivity limits, and also the geology and any references to sensitive areas or sensitive clay areas within the area before we confirm the behavior of such soils for the proposed development. So again, to summarize, so the objective of the testing was to collect moisture contents and Edberg limits and other parameters that we can use and put together to build a model for the foundation soils. That includes the RTD for bedrock as well, the consolidation parameters, the unit weight, the friction angle, and the shear strength parameters. In addition to this, it's always recommended to support the findings of the field and laboratory investigations using correlations from literature. So, and the correlations also help to validate the laboratory testing results or the field testing results, and also it helps when we have limited data available or questionable data, and helps to support the geotechnical model and come up with a proper design model for the foundation soil. And also it serves as a quality assurance check on the determined test results. This is just a quick summary of some of the results that we can highlight. Over-consolidation ratio of the soil was around 2 to 4. Pre-consolidation pressures not that high, so it's between 120 to 150 from the different samples that were tested. Also, triaxial testing was conducted to confirm the friction angle, or the long-term friction angle, or the effective friction angle of the clay, as well as the drain shear strength parameters for the clay deposit. So basically, we had to do different type of tests and sets in order to confirm the parameters and use the right parameters and the analysis as indicated before. Concentration testing, just an illustration of one of the results. So it helps us to always visualize the profile along the depth and a continuous profile, basically, from the testing. And it's always recommended to plot the some of the other field testing to confirm the CPT. So CPT, or the concentration testing, always use correlations and some empirical parameters in the prediction. So it's always recommended to compare it with other methods and come up with the right empirical parameters. And then the beauty of the testing will be to give you, what is missing between the areas where you don't have testing results. Here is just an indication of the sensitivity, not really a concern, and also was checked by other testing methods. So after we do a lot of testing, after we do a lot of field testing and laboratory testing and field investigations, we have to put everything together in one model in order to come up with a design line of the foundation soil to deal with in analysis. One way of doing it is just to put all the results side by side and just exclude or maybe redo some of the testing if you think some of the numbers don't make sense. And that's what we always have to do and deal with when we come up with geotechnical models for engineering studies. Maybe one thing to mention is just the liquidity index, which is a very important factor that we can calculate using the different Adderberg limits, and we can use this to confirm the sensitivity of the clay deposit. As I said, the depth of the bedrock was not too deep, and that was helpful in some way in the required support for the proposed mine facilities. Other considerations that we always have to deal with in mine waste management in general is what is the inflow and outflow that will be expected for the different facilities. So, for example, for the West Rock facility, we need to assume the right precipitation, evaporation, and any infiltration going into the facility, and predict what will be the basal seepage and what is the runoff that will be going to the pond. All of this can be done by the help of water resources engineers in order to come up with the right volume of water that will be expected as a result of the development of the site, which is an important factor, an environmental factor that has to be dealt with during the investigation phase. So as part of the feasibility study, and considering all the factors we talked about, and also considering the requirements from the expected volumes of materials, a plan for the development over the years get developed, and this was an important factor before we go into the design and checking the factor of safety, is to understand what the owners or the developer is thinking in terms of development of the facility and how it will be staged over the mine life. And based on this, now the stability models and other models can be created. So as you can see here, expected in 7 years to reach the maximum volume of materials, and the challenge is always during the last few, or during the last period of construction, how to deal with steeper slopes and less footprint. In the beginning, as the mine is developed, we have wider footprint. We can slope, or we can have flatter slopes. When it comes to the end of the mine life or the end of the production, now the whole footprint is being utilized. We have to make the slopes steeper, and we have to deal with more challenges as engineers to confirm the stability of the dams. So in order to confirm the stability, and which is one of the main aspects we deal with as geotechnical engineers, is to always use the right guidelines and refer to the right guidelines in the stability models. And that includes, for example, the Ministry of Natural Resources guidelines, includes the Canadian Dam Association guidelines and other guidelines that provide minimum factor of safety as an example, a design earthquake, another example, and other design assumptions, or maybe other design aspects would have to meet these requirements in the design stage. So as I said, as the mine is being produced, so different elements will have to be considered in the design. That includes maybe benching design, and like a geometry like this is helpful to reach the factor of safety with the steeper slopes. So this is something that maybe we require in order to design the facility to meet the minimum factor of safety that is that's required. Or in some cases for waste rock piles, how we can have the right, like the slope that the operator, like the developer is asking for, and also have the factor of safety that we're targeting. So maybe installing a shear key within the slope could help in reaching the right factor of safety. And we will go through this in a little bit of details in the next few slides. So as presented, so we have an idea about how the development will be staged during the mine life. So we have to check the different geometry of the facilities over the years. And as indicated, we start with flatter slopes and confirm the factor of safety, no issues with footprint. We don't have to worry about the foundation that much. We can assume the most conservative parameters, and the factor of safety will be high enough to meet the requirements, and we can reach the required elevations or the design elevation. Over the years, steeper slopes now gets a little bit tricky. We don't have enough space. We can reach still the elevation, but we don't have an issue with factor of safety. We can use the most conservative parameters, no issues. Now, let's deal with cases where, okay, we reach the entire footprint. And we, at let's say year 6 and 7, we haven't really reached the design elevation yet for the West Rock, but let's see if the steeper slope will still be safe. No, it is not, using the whatever parameters we were comfortable with for the foundation soils. So things now get introduced to in the picture to come up with a factor of safety that meets the requirement. That could include shear key. So shear key is one of the common methods to support or to increase the factor of safety for slopes. The issues that we have to deal with is water levels and how this can be controlled during the construction and also during the mine life. Also, you have to have good foundation. And in that case, we have the bedrock that's not too far, so we can dig into the superficial layers and reach the bedrock and have the shear key with the right dimensions or the right geometry that can have the factor of safety meeting the requirement. And we use the steeper slopes that is required. Now, another factor that we always have to probably deal with, and it's an important instability, and we can't ignore it, is that for clays, when they're loaded, they gain some strength, and this is something that we can consider in the design and could also help us in stability. So that was checked with steeper slopes, maximum volume. No, we haven't really reached the maximum or the factor of safety that was required for the development. So yes, we can still consider the consolidation, but we can maybe modify the shear key design and we can reach the factor of safety. So we deal with a lot of factors that can help us in reaching the design goals, and as well as use the right parameters. And we don't be too conservative, but at the same time, we have to be conservative enough, and we have to assume the right parameters for the design and reach the or meet the minimum factor of safety that is expected for the development, referring to the right guidelines, such as the Canadian Dam Association guidelines and others. Yeah, as indicated, so now we have the maximum level of or the elevation level for the facility. We can consider a little bit of consolidation and enhancement, and there are different ways of doing such analyses. We'll not go into that detail here, but as the clay is being loaded, the B-bar is getting different, and the shear strength is getting a little higher. You do sensitivity analyses and assume improvement in the shear strength parameters, and confirm this by laboratory testing, and how we can reach the right parameters and assume the right parameters for the improvement in the clay as the clay being loaded over the years, and also use the right slope for the facility, and come up with the optimum design of the shear key for materials estimations and excavation estimations, and so on. Benching is another method that also can be introduced during the mine life. So instead of reaching the elevation, if we have a room to pinch in the facility or the waste rock pile over the footprint or over the area, that helps in reaching the factor of safety and also maintain higher slopes. So it's another way of, instead of using flatter slopes, is to just bench the pile and use steeper slopes and meet the factor of safety that is required. So with some sensitivity analysis and assuming different dimensions of the benches, we can come up with the right geometry that can be implemented as construction during the mine life is being staged. Yeah, so sensitivity, and as an indicated, reaching the required elevations over the years is the main factor here, and also maintaining the right factor of safety over the years is an important element of the stability analysis. So as indicated, a lot of factors and a lot of assumptions are being made during the design of facilities like this, and in order to always maintain the stability and always make sure that whatever was assumed in the design is valid, is to instrument the facilities and the foundation soils, and monitor the different changes in groundwater levels, in stresses, and probably sometime temperature of the ground, in order to come up with a monitoring program that can help in confirming the stability and the behavior of the facilities with time. And that includes, as I said, instrumentations prior to construction and during construction, like as the development is reaching the right elevations, and also after construction, is to monitor and always keep records of the elevations of the groundwater levels and other measurements, and review this with whatever was assumed, and introduce any changes to the development as required during or after the construction. So that includes regular inspections for possible cracks, settlements, deformations that are not expected, monitoring of vibrating wire piezometers, settlement gauges, inclinometers to see lateral movements, flow meters to see any seepage and water inflow, regular elevation surveys, and in order to keep a record of settlements over the time, ground investigations to monitor clay shearing, in which case we can confirm what was assumed during the design for clay improvement, as the clay being loaded is confirmed during or after the construction of the facilities. Another helpful way of understanding the topography and also the elevations of the bedrock is using the geophysical methods and investigations, and such methods and testing gives us a very good profile of the shear wave velocity and other physical parameters of the subsurface layers, and this is helpful to confirm our findings related to the depth of the bedrock and the depth of soft clays and other parameters, and helps us to do some geodynamic analyses and also seismic analysis, and use the right earthquake design parameters, or whatever the parameters required for earthquakes or the seismic slope stability analysis. Other methods could include also electrical resistivity methods, which helps us to also sometimes detect lengths or layers of soft clays, and how we can deal with it before the construction of such developments. So this brings me to the end of this presentation. I really thank you for listening, and would like to thank the organizers for the invitation, and thanks everyone for attending.
Thank you very much, Dr. Sadeldin, for an enlightening presentation on geotechnical investigation study for the proposed waste rock and mine tailings facility in northern Quebec. So we read about several catastrophic mine tailing dam failures in different parts of the world, and how they become a major cause of environmental disasters. And for that matter, I think that both the talks that we have had today are very relevant and timely. So I think I cannot see any questions posted in the Q&A. So to the participants, if you have any questions for Dr. Sadeldin, please type it in the Q&A session. So, okay, I don't think they have any questions at this moment, but surely please feel free to contact Dr. Sadeldin for further discussions or for further queries. So what I personally feel is that learning from the experiences of practicing experts that provides a lot of inspiration and first-hand industry knowledge. And these information can also give us new ideas basically related to any type of waste storage facility. So it need not be a mine waste or a waste rock facility. It could be a storage facility for any types of waste. And all the key elements that was discussed in this session, and from the geotechnical and the geo-environmental point of view, all these key elements are to be considered while we construct or design a waste management facility. And it basically gives us a clear vision of what we should be doing on what we should not be doing in the future. So, and one more thing, the audience may not know this, but Dr. Sadeldin, we owe you a very special word of thanks for being here, because I happened to find out that you joined Stantec only a couple of weeks ago, and this is a very hectic time for you with all the official formalities. And so we really appreciate that you could join us here today. So
thanks very much. I really appreciate it. Yes, I rejoined Stantec. I used to work for Stantec in the past, and then I worked for Ontario Power Generation, where I was involved more in hydro dams and stability of hydro dams and inspections, and was an interesting time with them. But also now I'm just transitioning back to consulting and dealing with a lot of challenges and time constraints and developing investigations. But that's the nature of our work, and we always like to support our clients and do our best in our work. So thanks very much. I really appreciate your time, and thanks for the opportunity.
Yeah, thank you. We're really great to have you. We feel great to have you here. So now, as we are about to conclude our lecture series, I'd like to request Dr. Sumi Siddiqa to give a word of thanks.
Thank you, Dr. Cherian. Thank you, everyone. It was a great lecture series, and I would like to thank all the participants. I would like to thank all the speakers, especially today's speaker, Dr. Mishra and Dr. Sadeldin, for a great presentation of mine waste management, and we have learned a lot. I'm pretty sure audience have enjoyed. And also I would like to acknowledge the financial support came from the SICI Institute. This is a great initiation by the SICI Indo-Canada Institute, where they allow researcher and the practitioner to present their work and encourage other people to learn from them, and then exchange of knowledge, which is very important for to become innovative in our practices. I also like to thank all the audience from IIT Dhanbad and Dr. Chinchicharian and Dr. Shurabijan for organizing the event and making sure it runs smoothly, and all the participants and everyone who got involved during the process. So we will be sending out the certificates who have registered the lecture series, and we have your information, so we'll be sending out that certificates. And if you have any questions and further, if you want to know about any specific topic, please feel free to email any of us, and then we can get back to you on that. Thank you very much.
Thank you, Dr. Siddiqa, for your kind words. So once again, I'd like to thank all the participants for joining this session. So I hope all of you are going back with some fresh knowledge, with some with a bag of new ideas. And I hope you enjoyed the lectures, all the 4 lectures that we had. So we are looking forward to more of such opportunities, and we look forward to meeting with you all again. So I think that's all for today.